5 is multiple angles, and we're going to derive those using the sum identities that we learned from the last section. So here, a double angle, you can see here's u, which is your angle, and there's a 2 in front of it. And that's what makes it a double angle. So 2u is the same thing as u plus u is what's equal to 2u. So now we have sine u plus u. We're going to use the sum identity for sine, which is going to give us sine u cosine u plus cosine u sine u. And then you can see these two things are exactly the same. So that means we have 2 of those. So 2 sine u cosine u. And this is the first double angle identity. And I have it written for you right down here. All right, so now we're going to use the sum identity for cosine to do the same thing. 2u is the same thing as u plus u. Now I have cosine u plus u, which is equal to cosine u sine u minus, I wrote that wrong. Cosine u cosine u. Remember, those are the same for the sum identity. And then if this is a plus, this is a minus in between, and then we have sine u sine u. And so since we have 2 of those cosines, that's cosine squared. So it's cosine squared u subtract sine squared. Why did I put a c there? This video is going to be a little shaky because it's super late. Sine squared u. And there's my second identity, which is right here. Third identity, tangent 2u is the same thing as 2u is u plus u, and now we're using the sum identity for tangent. So sum identity is going to be tangent u plus tangent u over 1 subtract tangent u tangent u. And now we're going to simplify that. Tangent u plus tangent u is 2 tangent u over 1 subtract tangent u, and that's going to be squared. And so this is what I have right here. Okay? All right. So now, when we're doing double angle identities, cosine 2u can actually be written 2 other ways. So using Pythagorean theorem, we are going to identify the 2 other ways right now. So you see here we have cosine 2u, and we have cosine squared theta minus sine squared theta, which is the first one we came up with using the sum identity. Here you can see I have 2 more of those. So let's go through this and I'll show you how this works. We're going to start with cosine 2 theta is equal to this double angle identity, cosine squared theta minus sine squared theta. And what we're going to do is take the sine squared theta and we're going to rewrite it using Pythagorean. So Pythagorean is sine squared plus cosine squared theta equals 1. So sine squared theta is equal to 1 minus cosine squared theta. So that's what we're going to replace the sine squared with. So this is equal to cosine squared theta subtract, and now I'm going to put in what sine squared equals, which is 1 subtract cosine squared theta. And notice I use parentheses. Now distribute the negative. So this is equal to cosine squared theta minus 1 plus cosine squared theta. And you notice that we have 2 of those. And so that's going to equal 2 cosine squared theta, subtract 1. And there's the first second identity for the cosine of 2 theta, which is right here. So there's that one. Okay, so now we're going to do the same thing one more time, but this time, instead of replacing the sine squared theta, we're going to replace the cosine squared theta. So let's try this again. So the cosine of 2 theta is equal to cosine squared theta minus sine squared theta. And we are going to use Pythagorean. Oops. So Pythagorean, we have cosine squared theta is equal to 1 minus sine squared theta. So let's go ahead and replace it. So cosine squared theta is 1 subtract sine squared theta. And we still have subtract sine squared theta. Negative sine squared theta and negative sine squared theta is 2 of those. So this equals 1 subtract 2 sine squared theta. And so cosine 2 theta is equal to 1 subtract 2 sine squared theta. So here is the multiple angle for that one right there. So example 2, it wants us to find the exact value for cosine 2 theta. So it wants us to find the double angle. Given is cotangent u is negative 5, and it's telling us that it's between 3 pi over 2 and 2 pi. So the first thing we notice is this is the 4th quadrant, because here's 3 pi over 2 and here's 2 pi. Second, I don't really know my cotangents, but I do know my tangents. So tangent u is equal to the reciprocal, which is 1 over 5. Tangent is OA, which is opposite over adjacent. So if this is angle u, and you're going to draw a right triangle with the x-axis, we know that the opposite side is going to be 1, and the adjacent side is going to be 5. Here's your adjacent. Now, because we went down, we're going to go ahead and put a negative in front of the 1. Now, the first thing we want to do is we want to figure out this missing side over here. So to figure out the hypotenuse, we are going to do negative 1 squared plus 5 squared is equal to, and we don't know this side, so I'll call that side r squared. So negative 1 squared is 1, and 5 squared is 25, so 26 equals r squared, and so when we square root it, r is going to equal the square root of 26. By the way, the hypotenuse of the triangle is always positive. So this is root 26. Okay, so now we are going to go ahead and use our double angle identity for cosine. You have 3 choices. It doesn't matter which one you pick. I just picked this first one that we derived. All right? So looking at this triangle here, you have to find the, notice that we're going to take the cosine of u and square it. So what's the cosine of angle u? Cosine is ca, which is 5 over root 26. So here's what cosine u equals. Sine u is so, which is opposite over hypotenuse. So negative 1 over root 26. No need to rationalize. So now, let's go ahead and use the double angle because we're supposed to find the cosine of 2u. And let's just plug in what we know. So we know the cosine is 5 over the square root of 26. And we're supposed to square it. Subtract sine u is 1 over the square root of 26, negative, and we're supposed to square it. So when we square those, we're going to get 5 squared is 25, and root 26 squared is simply 26. And negative 1 squared is 1. Oh, there's not a subtraction though. It's a subtraction, not an equal sign. So subtract negative 1 squared is 1, and root 26 squared is 26. And now I have 24 over 26, which is equal to 12 over 13. And so that is what cosine 2u is equal to. Note, if u is in quadrant 4, then 2u, all right, if we're looking at the values of where we are, so here we are, you're going to have to take that and make it a 2u. And so you would multiply the left side by 2, the middle by 2, and the right side by 2. So this gives me 6 pi over 2, which is 3 pi. 2u is in the middle, and then 2 times 2 is 4 pi. So this does change our domain. The double angle is going to be between 3 pi and 4 pi now. So example 3, I'm going to show you how you can use double angles to help you solve this equation. So we have 4 sine x cosine x equals 1, and when you're solving an equation and you have both sine and cosine, it's really difficult to do. So what we're going to do instead is we're going to take the 4 and we're going to write it as 2 times 2, which is equal to 4. And then we have sine x cosine x equals 1. And our domain is between 0 and 2 pi. So now 2 sine x cosine x is a double angle. So sine 2x is equal to 2 sine x cosine x. So let's replace it. So 2 times, and now we have sine 2x is equal to 1. Divide by this 2, sine 2x is equal to a half. Just like we did last section, we're going to have 2x is equal to the inverse sine of 1 half. So where is the sine equal to a half? The sine is equal to a half at pi over 6. So 2x equals pi over 6. And the sign is also positive in the second quadrant. If you take pi, subtract pi over 6. So we know all students, so the sign is positive in the second. Here's pi, here's the reference angle, pi over 6. So pi minus pi over 6 is 5 pi over 6. But, oh, and then we'll do the 0 to 2 pi in a moment. So, but we're not solving for 2x, we're solving for x. So we're going to have to get rid of that 2 by multiplying by a half. So we'll multiply by a half, and then we'll multiply this side of the equation by a half. So now my two answers are x equals pi over 6 times a half, which is pi over 12, and x equals 5 pi over 6 times a half, which is 5 pi over 12. So those are my two solutions so far. Now let's talk about the domain though, because pi over 6 and 5 pi over 6 are both just in the first quadrant. But I am looking from 0 to 2 pi. So basically, I need to make this a 2x, and then you would multiply 2 to the 0 and 2 to the 2 pi. which means the double angle is between 0 and 4 pi. All right? So I am going to need to keep finding more values. So let's go ahead and look at that. Our original answers, pi over 6 and 5 pi over 6. So I have pi over 6 and 5 pi over 6. I want to go another unit circle around for 4 pi. So we're going to add 2 pi to each of these. All right, so we can do another full unit circle. So the common denominator here is 6. So we'll multiply the top and bottom by 6. Now I have 1 pi over 6 plus 12 pi over 6 is equal to 13 pi over 6. So here is my solution again. And then we're going to do 5 pi over 6 plus 2 pi over 6. Common denominator is 6 is equal to 5 pi over 6 plus 12 pi over 6 equals 17 pi over 6. And that takes me to 4 pi. And so these are my 4 solutions between 0 and 4 pi. Example 4, I'm going to take sine 3x, which is a triple angle, and I'm going to rewrite it as simply sine x, which is a single angle. So the first thing I did is I took 3x and I broke it into 2x plus x. So now I have sine 2x plus x, and I'm going to use the sum identity. So the sum identity tells me that I'm going to have sine, and your a is your 2x, so I'm going to have sine 2x cosine x, and then I'm going to add cosine 2x sine x. Now you can see I have double angles. I have a sine 2x and a cosine 2x, so I'm going to rewrite those using the double angle identities. The sine of 2x is equal to 2 sine x cosine x, and I'll highlight what I replaced. And then I still have cosine x plus cosine 2x. There are 3 double angles. I am going to use the 1 minus 2 sine squared x. So I'm highlighting what I'm going to replace. And then I still have the sine x. The reason why I did that is because this is sine here, and I wanted it all in the same trig function. So over here, I have cosine x and cosine x, which is 2 sine x cosine squared x, plus distribute the sine x minus 2 sine cubed x. All right, from there, I have cosine squared x using Pythagorean. And again, remember, I'm trying to get everything into sine x is what they asked me to do. So I've been moving everything towards sine. Cosine squared using Pythagorean is the same thing as 1 minus sine squared. So this is 1 minus sine squared x. And I'll highlight it. And then I still have 2 sine x. And then I have plus sine x minus 2 sine cubed x. And we want this all as a single angle. I'm going to go ahead and distribute the 2 sine x. 2 sine x times 1 is 2 sine x, and 2 sine x times sine squared x is 2 sine cubed x, plus sine x minus 2 sine cubed x. So plus sine x minus 2 sine cubed x. And you can see the negative 2 sine cubed x and the negative 2 sine cubed x. You can go ahead and add those together. The 1 sine x and the 2 sine x you can add together. So that's 3 sine x subtract 4 sine cubed x. Now the question asks us to write this as a single angle in terms of sine x, and that's exactly what we did. Do you notice that the x's do not have a 2 in front of it or a 3 in front of it? It's a single angle because it's just the x. So that's what we did. And example 5 is another one of those identities, just like a geometry proof. And so we're going to try to make one of the sides equal to the other side. So start with the most complicated side, which is the right-hand side, and we want it to equal sine 2 theta. So I have 2 tangent theta, and on the bottom, do you guys notice that this is Pythagorean? Anytime you have a square, check out your Pythagoreans. So 1 minus tangent squared theta is equal to secant squared theta. So now what we're going to do is let's rewrite secant squared up top with the reciprocal identity. So now I have 2 tangent theta cosine squared theta. And then let's use the quotient identity and let's rewrite tangents. So 2 sine theta over cosine theta times cosine squared theta. Then you can see that the cosine is going to cancel with one of those cosines. And now we have the double angle identity. 2 sine theta cosine theta is the same thing as sine 2 theta. Sine, notice the 2 in front of theta is what makes it a double angle. So that's equal to sine 2 theta. Check. So that is an identity proof. There's also power reducing identities. We're not going to do a lot of these. This is how you derive the power reducing identities, is through the use of double angles. Let's jump to this page and let me just show you what those power reducing identities are, and then you can check out the proof on your own. So here, when you have a sine squared theta, you can reduce it to a double angle to where you no longer have the square. So this is helpful if you look at example 6. If you have something to the 5th power and you want it to be to the 1st power, then you can use this power reducing identity. So let me show you how this works. We know cosine to the 5th is the same thing as cosine squared times cosine squared times cosine. If I multiply that together, I get cosine to the 5th power. So now we're going to take the cosine squared and we're going to replace it with this identity right up here. So, which is actually a double angle. So now I have 1 plus 2, no, not 2, 1 plus cosine 2 theta, double angle, 1 plus cosine 2 theta over 2. And you notice I have 2 of those cosine squares. So I'm going to have 2 of these. 1 plus cosine 2 theta over 2 times cosine x. And this is pretty cool because everything now is with a power no greater than 1. So yay! So we can just do a little bit of simplification from here. You can do bottom times bottom, which is equal to 4. And then if you want to FOIL the tops, 1 times 1 is 1. And then if you do outside insides, 1 cosine 2 theta times 1 cosine 2 theta is 2 of those. So plus 2 cosine. Oh, and you know what? These are x's, not thetas. Let's change those. Sorry, I switched from thetas to x's. And now we'll try to go ahead and switch back if this will allow me to erase. So go ahead and try the U-try. Number 1, you're going to be solving an equation. Change this double angle into a single angle to start with. Number 2, you're going to be doing a trig identity. And when you do your identity, start with the left side and simplify it to equal the right side. And then make sure you do your reflection question. Thanks.